Okay. Hello, hello. Hello, thanks so much for coming. This is a great crowd. True to Cleveland Big Data style, so we're going to start on time. We're going to I think we're going to let some of the presentation slide a little bit. I don't have my timer, so if you guys, exactly, just don't go too crazy. So again, for folks that don't know me, I'm Doug Meal. I'm the creator and organizer. And again, thanks so much for Emily, Ann, and Aud, because I thought I was going to miss this tonight because of a work commitment. But yeah, thanks for covering it and getting the pizza set up and the room set up. So this is a fabulous place to have a meetup. So again, thanks to KeyCorp for hosting it. Seriously, this is a great facility. And then, funny story about the pizza. So we had the pizza sponsor back out on Saturday. So booze, please. Boo! So Mike and I paid for the pizza. So if you enjoyed it, you're welcome. So we're always looking for speakers, and we're always looking for pizza sponsors. So hint. Also, always want to promote other meetups in the area. So we had an announcement from the Python user group. So come on up.
Hey everyone, my name is Anurag. I run the local Cleveland Python meetup. We meet every second Monday of the month. Our next meetup is on December 11th. We mostly meet online, but if your employer is willing to sponsor, we would love to meet in person back again. If you would like to present anything that is Python or Python adjacent, beginner to advanced, AI, ML, web-based, whatever, we would love to have you. Clepy.org is our site, clepy.org. Thank you.
And do we have any recruiting shout-outs tonight? Sorry if we're not getting these ahead of time. Any recruiting shout-outs? Going once? Oh, there we go.
I don't have a recruiting shout-out.
Oh, cool.
And we're going to be scheduled.
Oh, yeah, right there.
I co-host Cleveland AI with Ted Troxel, and we've had 2 meetups so far this year. We're going to have another one scheduled for January. Just be on the lookout. If you're interested, you can go onto our meetup page as well.
And so without further ado, let's do the talk from Mike and Azim.
Welcome everyone, and thanks for hosting us, or thanks for having us. I'm going to do some overview of what KeyBank's doing with generative AI in our roadmap right now, and then Azim is going to do a demo, and so hopefully it'll work. It'll be a live demo, and I think you'll find it interesting. So without further ado, I did want to thank Doug. He was coming late. I go, oh great, the time cop won't be here because this is going to be a little interesting to get through. But go ahead, Azim. You're going to advance. So if you don't know KeyBank, we're probably one of the top 20 banks, maybe top 15, 180 billion in assets, branches across the U.S., national presence with the National Digital Bank, but that's us, based here in Cleveland. Go ahead. This is hard not doing it with the slide in front of me. Fun fact slide. This is just, yeah, you can come up, I'll drive it, because I can't see the screen. Not that I'm going to read this slide to you, but just so you know, a very large tech footprint. We have made a decision to heavily partner with Google and move most of our data to Google. I'll give you a few fun facts on that, on what we're doing at Google. We used to own 2 data centers. We are no longer owning data centers. We have a co-location in Chicago, one in Reston, Virginia. And our intent is to not own data centers and move everything we can to the cloud. And if you can't go to the cloud, it'll go to a colo and run that way. So just some fun facts on us. These slides Doug will share, so right, you'll share all the slides. So if you want to read more about it, a little bit about everybody's talking about Gen AI, right? Every presentation I go to, every vendor is going to put LLMs into their software, and it's the buzzword of Gartner hype cycle. It's probably at the peak of heightened expectations, and we'll soon go into the trough of disillusionment. But artificial intelligence started in 1956, right, Doug? A long time ago. And then machine learning. You know, this slide actually came from Microsoft, I think, but They say 1997, but I actually got my graduate degree from the Ohio State University in computer science in 1989 and studied neural networks in 1989 for artificial intelligence. So it was going on way back. And so what makes it so interesting now? Because deep learning started in 2017. On the right-hand side, stuff is moving really fast, right? The machines are learning really fast. That's what's interesting. The other interesting comment I've heard is that, you know, when model was just using numbers, and, you know, we've been doing modeling here at Key, we probably have 300 models. You know, predict attrition, predict next best product, predict pricing. Most of those were regression models, right? Math-based, you need to be a data scientist, right? What's interesting now is, you know, the computers understand letters, not numbers, and they can understand words, and that's amazing to people when the computer can actually respond and create stuff, and that's called generative AI. But it's moving really fast. And so what is it, right? It's a broad term. People refer to, I think the biggest thing is the things on the left, right? It understands audio now, it understands pictures, it understands words, and it can generate pictures and it can generate words. That's what's really cool for people, right? And it's self-learning, and you've got a lot of competition in this space. Bill Gates thinks it's really cool and it's going to be better than the graphical interface, but everybody's embedding it, everybody's using it. So for us, it's like, how do we use it, right? And then the other thing, just another context slide to get people on the same page, right? People know the word ChatGPT, right? ChatGPT was built by OpenAI, was released by OpenAI, but OpenAI does other things. They have DALL-E, which does, you know, more image management. It has Whisper. And then Microsoft made a big investment with OpenAI, so a lot of the Microsoft LLM and Gen AI stuff is going to be a partnership really between OpenAI and Microsoft. Google, on the other hand, is building their own. They use the term Bard right now. There's a couple other terms they're throwing around. So we have a partnership with Microsoft because of Office 365 and Teams. We also have a partnership with Google. So we're actually playing in both those sandboxes. The slide on the right just talks about how fast ChatGPT took off and compared to other technologies. So it's a fast-moving space. And then for us, there's four, you know, major, I'd say, use cases that generative AI can be used for, right? Content generation, that's the generative part of AI. So generating documents, PowerPoint slides, job descriptions, generating fraud case write-ups, generating suspicious activity reports, or content summarization. Hey, we've got all these bank policies and procedures. We have like 15,000 bank policies and procedures. So can we use large language models to interpret that if someone asks a question and locate the right procedure? Code generation, Azim will talk about it a little bit. There's co-pilots now, both with GitLab and GitHub, and how to make your programmers more productive. We're doing some POCs both with GitLab and GitHub in that space right now. If we have time, Azim will speak to that if Doug doesn't cut him off. And then the semantic search and how to use LLMs for better search and locate. And for us, you know, lots of use cases in banking, whether it's, we have a chatbot now, so chatbots aren't unique. If you call most banks, you're going to get a voice response unit. It used to be just a primitive touch 1, touch 2. Now they understand language. And so will it be an improvement? Yes, it'll help. It'll maybe sound better. Maybe it'll understand what you're saying better, but not like going from 0 to, you know, something. It's been there for a while. It's just going to get better. Generate synthetic test data. We can see it used in application development, risk modeling, fraud detection, marketing. So lots of use cases, mostly back office. You won't see banks put this in front of a client or pricing models because the risk and regulatory teams have a lot of concerns about that, especially around bias. We'll talk about that. So we've given presentations to our executives. We've given presentations to our regulators. There's risks associated with generative AI. You hear them out in the industry, deep fakes. Like you can fake a voice, you can fake image, you can fake people. And from a fraud perspective, that creates a lot of concern. If you're on the Zoom call, can you mute? Thanks. So it can generate what people call hallucinations. You know, it's really not a hallucination. Someone once said this, everything ChatGPT, everything a large language produces is a hallucination because it really doesn't understand anything. If you say like, where's the nearest best pizza store, it doesn't understand pizza, it doesn't understand any of that. It just, based on what it's been taught, knows that the best word in the best location is this. There could be significant costs. That's one thing you don't hear a lot of people talk about right now is the cost. all about the use cases, but no one's talking about, well, how much would it cost? And no one actually has done a good cost model, because I think this is just like any other new technology. They want to get everybody hooked on it, and then they'll tell you how much it'll cost, and then you end up paying it, right? Output bias, just like model bias, there's just a lot of concerns about bias. And I can't see this last one. I think that maybe black box problem, just not being able to explain it, right? So for all of our models, the government regulators will say, can you explain how you gave that recommendation? Because they want to make sure you're not using bias, whether it was data bias that you trained the model on or it was an output bias. So if you can't explain how it came up with the answer, that's a concern to the regulators, especially if you're doing any kind of pricing or underwriting or decision making about loans. You need to be able to prove how did you come up with that answer. So you won't see us do it in a client-facing or a pricing use case for a while. All right, I've lost. So for us as a bank, we had to form an advisory group, right? So we have legal involved, compliance, regulators, or not regulators, our third-party risk management, human capital, right? So all these people weigh in on what use case and do they approve and do they understand the risk. So that's just, if you're a fintech startup or if you're a startup, a lot of times you don't have to deal with this. If you're a bank, you have to deal with all these people and the regulators that come in and question you on all these things. So we started this back in probably in March, and we've been running through it, and we have a bunch of use cases that we're presenting to people and getting their approval. So in general, right now, as I said, we have about 24 use cases that people have submitted. We think of it I would think of it in three broad categories, right? If you're looking at this, one is this ChatGPT interface. Can you come up with key GPT, right? That any employee could ask it a question and it could come back with an answer. So we're looking at what Google's doing in this space, or we're looking at what Microsoft's doing in this space to provide an internal GPT-like service that protects our data and protects our employees from doing stuff that's bad. The second use case I would call maybe that API column is custom developed. You're going to hear today some custom development frameworks that we're looking at, because if you just use the LLM, it's just one component of the solution. You actually need some pre-processing and some post-processing around that. So that'd be custom development. And then the third area would be vendor-delivered capabilities. I expect every vendor we use to embed LLM somewhere, right? They're saying it. Every VC you talk to wants to know how they're using it. Whether it's ServiceNow is going to embed it, Salesforce is going to embed it, Adobe is going to embed it, our fraud vendors will embed it. So it's going to be embedded in everything, but our third-party risk, our model risk management team wants to understand what model they're using, what was it trained on, and can you prove that the answers are doing it. So it becomes a little harder for us to manage every third-party vendor we have to understand what model, what language model did they train it on, what is that model producing, and can we validate it. I think, is that my last slide? One more. So this is there's this term called RAG, you'll hear in the Gen AI world. It stands for Retrieval Augmented Generation. So I'll walk you through this framework a little bit. Azim will show you actually as he goes through his demo how we're building it. But it's basically, if a user asks a question, this actually happens a little bit with ChatGPT, because if you ask ChatGPT a question and then you ask to kind of follow up on it, the large language model has no persistent memory, right? So you have to keep track of what you send it. So the way it works is if you send it a question and you want it to refine it, behind the scenes it's sending the original question, the original answer, and the second question, right? Because it has no memory of what the first question was. And then if you ask it again, it's going to send the first question, the first answer, the second question, the second answer, and then the third question into the engine to say, here's what they asked for, so it has context, right? So think about that, and that's part of this pre-processing, right? So this prompt engineering is when someone asks a question, it's more around, hey, let me structure this prompt better, because the user probably doesn't understand how to structure it in a way to be efficient. And then if you're using your own content, on the right, there's content preparation that has to happen, right? Because the model wasn't trained on your content. I mean, this is something else we learned as we get into this. So unless you're going to train that model, which is a very expensive process on your own content, you have to send the relevant content into the model and then ask it the question. So you have this almost semantic search that says, hey, if I got 50,000 documents and you ask a question, I'm going to try to find the 10 or 15 documents that are most likely to answer that, pump those 10 documents into the LLM with the question and ask it to summarize it. Kind of a weird thing, because you would think that, oh, I could have just sent it at all my content, but you can't. And you can only send so much data into one prompt, so you can't send 50,000 documents in, right? So there's this pre-work, and then when it comes back, you either got to log it or do some post-processing to validate that it's accurate before you send it back to the user. And if the user asks again, you may go into your log, pull the first or second question, send it. So it's just, that's custom development, right? So that's kind of what you're going to see when Azim demos what we're doing in that space. And then one of the things he's going to demo is actually interesting. So I'll just give you a couple fun facts. We were a Hadoop shop. I worked at Explorus when we did early Hadoop with Cloudera and Doug. And then when I came to KeyBank 10 years ago, we put Hadoop in here, built a big Hadoop cluster. And then over the last 3 years, we've been dismantling Hadoop and putting it all on Google. And by the end of this year, in 6 weeks, we'll be completely done with Hadoop, and everything will be running in Google on BigQuery. And we have about 20 enterprise marts, big giant marts in Google that have about 1,000 tables and 50,000 attributes on them. And then in the user space, user workspaces, about 70 kind of workspaces the users use, there's another 50,000 tables. Now my pet peeve always, and I've been working with Azim on this for a couple of years, is like, because my son worked here for a couple of years, and he'd say, Dad, where is the fee we charge to a commercial customer when we originate a loan? And I'd have to call Doug Knopf, who works for me, and say, where is the fee? And he'd have to call the data architect and say, well, it's in this table, this column, this mark. I go, that doesn't scale very well. So one of the things we're doing this pilot on is how can you use LLMs to understand the schemas, the 1,000 tables and the 50,000 attributes. So when someone asks a question, it'll learn from that and be able to say, hey, this is the schema and this is the query that you need to write, and save them from calling me. So you're going to see it. We did a hackathon, and so it's kind of like not polished, but you'll see the genesis of this idea of using a large language model. And with that, I'm going to have Azim come up. He did the hackathon, but he'll tell you what we're doing in this space.
Thanks, Mike. Thanks, everyone. So before I switch, I wanted to show this meme that I found online. This is how I feel like how fast the AI world is going. If you haven't seen the movie Interstellar, this is a classic scene where Anne Hathaway asks the other astronaut what's the cost of this hurdle that we just went through. He says 1 hour here is 7 years on Earth. That's exactly what's happening in the space. So just a quick background of me. My name is Azim Sheikh. I've been with KeyBank for the past 8+ years, focused heavily on emerging technologies. We do in KeyBank we do annual hackathons. One of the ideas that we did during this year's hackathon is a data analyst copilot. We did not name this as copilot after ChatGPT's agents release, but this is essentially what ChatGPT has released a week ago in terms of customized agent for different use cases. So at a very high level, like Onders mentioned, we have so many data marts. The problem that we're trying to solve here is to cut down the amount of time that typical analyst would take to answer a business question. So instead of I know a guy who knows a guy process, we have a subject matter expert, which we call data analyst copilot, where analysts can go ask natural language questions, which these questions go through a large language model. In response, the large language model would give an analyst a clear identification of data sets, columns, table names, logical explanation as to how it arrived at these data sets, an executable query that an analyst can copy, paste, and run in a SQL editor to validate the responses, and sample results. Obviously, we wanted to see the sample results. And towards the end, it gives a natural language summarization of the business response to the business questions. So let me switch to my notebook. So I used LangChain to demonstrate this. Obviously, we wanted to develop this model, this application in such a way it is model agnostic. Let's just say if there is a new model which takes more tokens to give us response, we wanted to switch from a drop down and use another model to get the response. So while we were developing it, we used a model from OpenAI, which takes 16,000 tokens at a time and gives us a response. So I used a SQL agent here. As you can see, it's in the code. I'm using a model, and this is my connection string, which is pointing to a data set on top of BigQuery. So I have some predefined questions here. Again, there is no hard-coded information here. It's just the questions I wanted to save as much as time as possible. So I'm going to run a quick query here and see what exactly it responds us to. So all the response you see is actually the response from large language model. I did not tell the model to look into a specific table. It scans the entire schema and then gives us the thought process as to how it arrived at the response. So as you can see, let me scroll back. You can see the thought process here. It says the relevant tables for this question are dim table fact range. I can join these tables on this ID, so on and so forth. It gives us actual executable SQL query. That's the sweet part of it. So you can actually copy, paste, and run this in a SQL editor. Well, you might ask me a question. This is probably a simplest question, right? So let's ask a much more complex question. I'm going to ask another complex question here. So I asked, what are the commitment amounts and outstanding amounts by industry type, risk type for the month of July 2023? Sum all the amounts. I hope it's not going to break, but yeah, let's see. So as you can see, it's actually scanning through the data set and coming up with a thought process as to what needs to be, where analysts can go and find those particular columns and records. So it says, I can see that the relevant tables are this and this. I can join these tables to get commitment amount, so on and so forth. The sweet part here is, it actually gives you the SQL statement with all the joins required to get this data. So just imagine the amount of time it saves for a typical analyst to go through, identify tables, run a couple of queries, and finally come to a conclusion, hey, this is my data, and this is the data that I need to actually tell a story about. So yeah, I think that's pretty much about the data analyst copilot hack that we did for the hackathon. Let me move on to the developer productivity study that we're doing right now in KeyBank. So KeyBank's version controlling software, which is enterprise supported in KeyBank, is GitLab. GitLab wrapped a bunch of Gen AI capabilities under an umbrella which is called GitLab DO. So we identified several developers and engineers within KeyBank, and we thought, hey, why don't you just start using it for a limited amount of time and test it and tell us, is it really helping you? If it's really helping you, in what areas is it really helping you? So we got some, it's still, the developer study is still under the process. So some of the interesting findings, I grabbed some screenshots and I thought I would share here. Amongst all the features that GitLab provides, code suggestions is top rated. Our developers say it's actually saving them more than 20% of their development time while using code suggestions. There are other features like GitLab DO chat, code explanations, code review summary. I'm going to share some of the screenshots now. So this is code chat. As you can see, I have a YAML file here, and then I asked my chat to, hey, help me explain what exactly this configuration file does. You can see the summary of what this configuration file does. Well, that's not enough. So if I have a repository with so many different types of files, I wanted to ask GitLab chat to explain me, hey, what does this repository does? I wanted to make a documentation out of this repository. Can you help me? You can see the second chat here. It goes down through each and every folder in that repository and gives a detailed explanation as to what this specific file does or folder does, so on and so forth. Let's move on to another feature that we thought was really interesting. This is root cause analysis, one of the features that GitLab provides. So we tested this root cause analysis on a failed CI/CD pipeline. This is a failed CI/CD pipeline, and this is about 700 lines. And we asked GitLab to, hey, give us the root cause analysis. It came back and say, hey, there is this one file that you're missing. Why don't you better write that file and rerun it? An interesting screen grab here is there was one merge request which was really huge in terms of updates. And we asked the Gen AI to write a merge request summary. It gave a really good summary as to what exactly this does. So we asked our developers, hey, would you write the same merge request if you were to write? He said we wouldn't be this much descriptive. We probably write a couple of lines, but this is more explaining more and better than me. Obviously, everyone's favorite, code suggestions. As you can see, you start writing the comment, it will prompt you with the suggestions as to what exactly you're trying to write. If you don't like it, just go backspace, and then it will generate another version of it. So I thought it would be interesting to grab some screenshots of it. With that, I think another proof of concept that we are running is Key Pro, where we are actually putting all the knowledge base articles, PowerPoint presentations, documents under one large language model, which is by Google. And then we are creating a question bank type of interface where you can ask questions and all the responses are based off the knowledge that you're provided to this large language model. Well, I think that I covered pretty much on time. Yeah, thank you.
That is really cool. Next up is Mike George. Whenever you're ready. Imagine you're a professional athlete, baseball, football, basketball. You're really, really good at your sport. You've been doing it your whole life, and you're on a professional team. The team has done really well this year. They've made the playoffs. For the first time in your life, you're in a playoff game at that level. It's arguably the most important game of your life. Imagine you're the pitcher. You're on the mound. You've got the ball. The umpire gave the signal, the batter stepped in the box. You know the batter, you know his weakness, you know what pitch you're going to throw, and you're visualizing that pitch before you throw it. On the football field, you're the kicker. You've got the ball in your hand, you've massaged it, you put it in a tee, and you've taken your steps back, you've measured your steps, your hand's in the air. You know where you want that ball to be placed, and you're visualizing your kick landing exactly where you want to put it. The basketball court, your center court, referee's next to you, whistling in his mouth, he's holding the ball. Look at your opponent. You're imagining the ball at its apex, and you're knowing exactly when you're going to jump. You're visualizing tapping that ball to one of your teammates. I want you to think about that athlete, what's going on inside, the adrenaline that's pumping in there, the emotions that are just overwhelming, the pent-up energy waiting to be released in the activity that defines you as a human being, the activity of the sport that you love. Now, multiply that times 50,000, and that's what it's like to be in the starting area of the New York City Marathon, 53,000 runners. Now, the athletes I talked about, they've got space around them, but when you're in that starting area, you're crammed in like cattle in a corral. Shoulder to shoulder, chest to back. The air is filled with anticipation and filled with that energy, waiting to be released. I mentioned corrals. Interesting, during the running boom, at the end of the running boom, when marathons and big races started growing, the organizers tried to figure out a way to get the race started smoothly, so they set up corrals, and that's what they call them. So you feel like you're in a corral, you're in a corral. They set the first corrals up near the start line with the faster runners. When you register for a race, they try to determine how fast you're going to be in that race, and they assign you to a corral, usually 2,000 or 3,000 runners per corral. Depending on the race, dozens of corrals maybe. A lot of races do multiple start lines. There we go. How do I advance? There we go. Sorry about that. About me. I've been working at Progressive Insurance for 17 years. I'm a distributed systems engineer. Unix, Linux. I still say Unix because most of my career has been with Unix. The past 10 years I've been working with Hadoop. Every cluster that's ever been built at Progressive, I've either built it directly or I've been involved in the construction of that cluster. The clusters that are in place right now running,
have been built with Ansible scripts, so DevOps, right? Infrastructure as code. I love my job. I love working at Progressive. I love my coworkers. I'm also passionate outside of work about running long distance, as you can tell. I have run many dozens and dozens and dozens of marathons. I've also run longer races. If you see anything red on your screen, please do a search engine and look up that. These are races longer than a marathon. The latest craze is called backyard ultras. Fascinating sport, really, really, really different. In my lifetime, I'd estimate that I've run at least 50,000 miles. That's just a guess. And I want to start the talk out here with a video. This is visualizing victory, fleeting joy, and hopefully... I love that video, and you know, that video is very applicable to this group. Doug, affectionately, every email, greetings, nerds. Okay, and if I could say so, this woman she would fit in this group very easily. Okay, my agenda is really brief. I've got just two topics. I'm going to talk about really, really big marathons and improving the experience through technology for the athletes that are in those marathons. Also improving the conditions for the race directors and the folks that organize these races. And then I'm going to talk about motivation and heart health, and it'll fit in. I've got 4 action items at the end of my talk, and I promise you, near the end, one of the slides I have are the words statistical predictor. So remember that. Okay, go back in time to the 1970s, and this is when the running boom happened. Frank Shorter and Bill Rogers were household names in the 70s. Frank Shorter won the Olympic marathon in 1972 in Munich. Bill Rogers won several Boston marathons in a row. The special thing about these two guys, the American public saw them and thought to themselves, that's a regular Joe. I could do that. And by the hundreds of thousands in the 70s, people put on running shoes and went out and started running. Near the end of the 70s, there was a guy named Jim Fixx, okay? Jim Fixx wrote a book on running. Okay, really? Running? One foot in front of the other. Somehow he got the material to put together a book. Anyway, look up Jim Fixx. Important couple items about Jim. I want to know, I want you to think about what he died from and how old was when he died, okay? He wrote this book. It was #1 bestseller for 11 weeks on the New York Times bestseller list. That's how popular running was in the end of the 70s. Okay, the Boston Marathon, for example, in the 60s, they were lucky to get a couple hundred runners at each race in the 60s, but by 1979, they had 8,000 runners. And it's still here with us. The running boom didn't go away. It just grew and grew and grew. 2019, 53,000 runners in the New York City Marathon. I think that's still the record for a number of participants in an athletic event. Okay, so during the 90s, there were 2 technical changes that happened that improved the conditions for runners, athletes, and for the race people. That was applying RFIDs to the individual runner. Each runner in a race would be provided with an RFID tag, and that way they could be tracked throughout the race. Before that, it wasn't such a fun experience for the slower runners. I'll explain in a minute. The other one is the internet. I don't need to tell you about the internet. I think you guys know about that. So, what was running like before those 2 things were around? I ran the London Marathon in 1992, and it was fun. There were some areas where the experience could have been improved. First of all, my registration, I did not chisel in a stone tablet my registration entry. I actually filled out with a pen and paper a registration form. I wrote out a check. I put it in an envelope, put a stamp on it, international postage. This was going to London, okay? There were 83,000 people applied for entry in that race. Unfortunately, they used a randomness to select only a few. I think less than half of that were selected to run. So it was a lottery system that they had set up. 24,000 runners finished that race. Before the internet, the results were kind of difficult. I ran the race in April, all right? It was at least 6 weeks later, I got this in the mail, the official results book, okay? And you can see this here, 59 pages of this. It took me 15 minutes to find my page, find my column, go all the way down to the bottom. Oh, there I am. Interesting. And I knew this was going to be this way, but my race time was 2.5 minutes slower than I really ran a marathon. All right? But I knew I was going to be that way. A little bit less than perfect experience. And this is why, okay? I was in the corral. I think my race bib number was 9,000 something. They had set up 3 starting lines. Each starting line had somewhere between 8,000 and 9,000 runners. And this is the start of one of those starting lines. Around 7 miles, those converged into one route. But imagine if you were at the back of that 8,000 runners. There was only one time, race time. The gun goes off, your time's going. It takes you 15 minutes to get to the start line because you got to wade through a sea of, you're tough luck, sorry. Now, everybody has their own watch and they keep their own time, so really, you know what you did, but the official results don't show that. All right. I took these numbers and crunched them a little bit just because I want to talk about the finish line now, because that's kind of, with that many runners, it's a little bit pandemonium. 15 minutes around a 4-hour timeline of the marathon, 15 minutes, 4 runners per second were crossing the finish line. And that's a lot of seconds in 15 minutes, and that's a lot of runners crossing the finish line. That image right there is Rosa Mota. She won the women's marathon in 1991, and that's looking at her entering the finish area. She's the only runner there. Look at all the dozens and dozens and dozens of volunteers that were there just to keep track of the times for all the finishers. When you have a big job like that that's manually difficult, you just divide and conquer, so you get a lot of people doing it. They set up lanes. They had about 7 or 8 lanes. When a runner finished, they'd run in a lane. At the head of the lane, a timing device was a person controlling that timing device, and it would print on a thermal paper every time a runner crossed, you'd hit the button. It was manual, okay? That tape would get 100 or so times on it. When the runner finishes, he would tear off a tag, the bottom part of his race number, and hand it to a volunteer or a race official in the finish area. They would keep those in order. They'd be very careful to make sure those slips were in order. About 100 slips, and they would take that along with the tape and hand it to somebody who would go off to a room somewhere and collate. Lots and lots and lots of manual work. But they had lots of safety nets in here, lots of redundancy, and it worked, okay? It worked. But it was a huge laborious effort, not needed with their RFID. This is what the RFID looks like right now. It's a foil embedded in the back of the race number. It's really cool. The antennas, and they set up multiple antennas. They set up an antenna at the beginning, antenna at the end. When you cross over an antenna, that radio frequency hits this foil, and the foil it's not energized, but it replies like with an echo. I don't know, I'm not a physicist with radio waves, but this echoes back a very unique identifier. That antenna is attached to the computer. That identifier says, oh, this is race bib number 415. On the computer, 415 is associated with Mike George. These are what the antennas look like. They're mats that you roll across the ground, and the runners go across them. They set up mats at the start area and at the finish area. So when you run a marathon now, your time for your race doesn't start until you cross that start line. The benefits of RFID, really a bunch of benefits, but primarily each runner gets their own clock. No more of this 12 minutes added to your race time because you were at the back of the starting areas. Live results. If I'm in London running the marathon and I cross the antenna at the 10-mile mark, my wife could be over here in Brecksville looking on the computer, and within seconds she knows, oh, Mike's at the 10-mile mark in London. He's doing really well. Checkpoints to reduce cheaters. Look up Rosie Ruiz. It's a hilarious story. If you've never heard of her, she is the most famous marathon cheater of all time. Cheating is prevalent in all sports, unfortunately. With RFID, very difficult to cheat, very easy to get caught. Now, big benefit to the race promoters and the race organizers is they get to do more entrants in the race, and it's less expensive manually. All those manual tasks are eliminated by the RFID. So and marathon running is a business. They're out to make money. They're not going to run a marathon and go bankrupt. Okay, so present day. A little bit about registration. The London Marathon gets about 500,000 entrants for each race each year, and they use the internet exclusively. They set up a date and a time to start registration, and then after a period of time they close it. 500,000 entrants. Unfortunately, they only select about 10%, so 90% randomly get put aside and said we can't afford to have you in the race this year. Last week, now 11 years after the London Marathon, I ran the Chicago Marathon, 2003. And last week, I went to the internet and looked up my results, and it took me about 10 seconds, which is way big improvement over the 15 minutes looking through a booklet here. Really good experience. Better, much better experience. Okay, now my second topic, heart health. And there's a couple reasons why I'm talking about heart health. I think it fits in because running is supposed to be one of the best activities to promote heart health. Eating is the other one, but I won't talk about that. Okay. You didn't see me eat pizza here today, did you guys? No? Okay. All right. So, heart disease is the #1 cause of death in the United States every year, 700,000. It's a big number. It's the important number. Okay. October last month was Sudden Cardiac Arrest Awareness Month. And there's a lot of people, the general public doesn't understand that a heart attack and sudden cardiac arrest are not the same thing. And hopefully I'll give you some information in a minute here that'll help you understand that. And then I've got 4 action items after that. Okay? To understand heart attack versus cardiac arrest, you need to know a little bit about the anatomy of the heart. The heart has 2 systems. There's the plumbing and there's the electrical. The plumbing is what brings freshly oxygenated blood to the heart muscle tissue via the coronary arteries that lie on the surface of the heart. Your heart beats between 50 and 80,000 beats a day. That muscle tissue needs freshly oxygenated blood constantly. If there's a disruption to that blood flow, muscle tissue gets injured, you feel pain, and if you're smart, you'll take an ambulance ride to the hospital. You'll get checked out. Good scenario, you'll come home in a few days with a handful of different medications that you need to take. That's a heart attack, okay? Sudden cardiac arrest is related to the electrical system of the heart. Interesting thing about the electrical system of the heart, it is not connected at all to the neurological system of the brainstem. So it's a separate neurological system altogether, the heart. It's got an A node and a B node. They communicate with each other. It causes the heart to bump, 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 bump. There's a little delay there. Upper chambers, lower chambers. If there's a disruption or if there's a confusion between those nodes and the electrical system goes a little bit different, your heart doesn't get blood to the organs of your body, including your brain. You go unconscious, you stop breathing, and technically you're dead. Case in point, Damar Hamlin. If you don't know who Damar Hamlin is, 10 months ago on Monday Night Football, young athlete on the football field, he dropped and fell unconscious, and for a few minutes he was technically dead. He did not have a heart attack. He had sudden cardiac arrest. Now, often sudden cardiac arrest is caused by heart attacks, but not always. Okay, anybody a fan of The Princess Bride? I love that movie. Okay, Miracle Max, I got some hands here. All right, Miracle Max, who's he's dealing with a person who is visibly dead, and he's talking to the friends of this person, and he's studying and goes, you know, I got some good news. He's not all dead, he's only mostly dead. That could be said about Damar Hamlin, and that's one of my favorite movies, and now one of my favorite lines. He's not all dead, only mostly dead. Okay. About 1,000 times a day in the United States, someone suffers from sudden cardiac arrest, okay? And the outcome is not usually very favorable, all right? I've got that little graph on the side there. If you pass out and it's 9 minutes before they defibrillate your heart, get it started again, and get you breathing again, that 9 minutes, your likely chances of survival are 10%. All right? Out-of-hospital cardiac arrest is the most common. Actually, most cardiac arrest happens to people when they're in a house. Sometimes it happens when they're at the park, they're at the bowling alley, they're at a fast food restaurant, waiting in the takeout line. Right? Out-of-hospital cardiac arrest, typically it's a 7% survival. So 95% of the time, you're either going to die or you'll go home severely disabled. Here's my action items for you, and there's 4 of them. The first action item is look up on YouTube CPR. Very important, CPR. It's a 2-minute video clip, it's very easy. Back in the 70s, there was a band called the Bee Gees. They made this song called Staying Alive. That rhythm is the perfect rhythm for the heartbeat. So CPR, do that rhythm. Second is know where the AEDs are. You know what? When I came in here today, I didn't see an AED device, and I'm very astute to where they are, so I track them. But there's a video clip that you can watch, shows you how easy they are. They're automated. You open it up, it talks to you. It tells you where to put the pads. It activates based on what it's sensing from the patient. Item 3, if you're not seeing a physician annually, go see your doctor. Get your cholesterol levels checked, make sure your heart healthy, follow the advice of your physician. Now, item 4 is a really cool one for Cleveland folks. University Hospital has received tons of grant money. They do what's called a coronary calcium score, and it's free. If you go to this link and register, they won't even ask you about insurance. They just sign you up and do the test. It's a battery of tests. There's a handful of tests, okay? The result of those tests is a statistical predictor of future coronary events in your life. Okay. Now I'm going to get really personal here. This goes to 2020. Everybody remember March of 2020, COVID hit, and all of a sudden nobody had to go to work, including me. I didn't have to commute anymore, so I gained 90 minutes every day in my schedule. And what do you think I would do with 90 extra minutes a day? Okay, this is my training schedule for April and May and June, and each green line represents a day where I ran miles. The little blank spots are where I didn't run, so I think about 10 days in April and May I didn't run. In June, I ran every single day. In July, I ran every single day. August, I ran every day. 3 months in a row, no days off. 2 things in September I want you to look at, okay? I've got a big tall line there on September 12th. I ran 26 miles that day. It was during COVID. I had registered for a marathon, and all the marathons got canceled. Well, the race directors, all the race directors, offered what they call a virtual marathon experience, right? You use your GPS to run in your neighborhood, and you provide that to the race directors, and then they'll send you a T-shirt and a finisher medal and a certificate saying you ran such and such marathon as a virtual marathon, okay? 11 days after that, I stopped running. There's no runs at the end of September. On September 23rd, I ran at lunchtime with one of my coworkers. We met in the national park and we did 5 miles. That evening, I died for the first time. I suffered sudden cardiac arrest. There's a common phrase out there, serious as a heart attack, and that's appropriate. Heart attacks are very serious. If you do an internet search on sudden cardiac, you'll find that a lot of medical professionals are changing their nomenclature. They're saying sudden cardiac death. Okay. Another thing I want you to look up is therapeutic hypothermia, because that's one of a couple reasons, but I'm here. It's a good story. I had saviors. I had people that took care of me. I don't know if you can see this, but they were workers at Arby's. I was at a drive-through line for a fast food restaurant when I went and passed out. My wife, I was in the driver's seat. My wife put the car in park, and she hit the SOS button, Starlink. It's the Subaru version of OnStar. Okay. She jumped out of the car and started screaming for help. 3 people came out of Arby's. These people right here, strangers. They came to the aid of my wife. Amanda, who's in the pink shirt on the far side, she sat in the car and talked to the emergency responders to make sure they knew exactly where they were going, while the other 3 took care of me, my wife, and the guy there, his name is George. I'm sorry, his name is Billy. His name is Billy. I'm George. A little bit deceptive here. Billy gets out of the restaurant, and my wife sees him, and he's no taller than my wife. My wife weighs 100 pounds. I'm 200 pounds. They need to get me out of the car. I'm seated upright. Billy, deceptively, he's a gym rat. He's muscle-bound. His arms are as big as my legs. And I'm a runner. I've got big legs. He got me out of the car and laid me flat on the pavement very quickly. That's key because I had oxygenated blood in my system. When he laid me down, that removed gravity as a hindrance from oxygenated blood reaching my brain. My wife, who is next to me, and Stephanie broke my ribs. CPR works. And I'm here telling you, evidence, my mouth, CPR works. Suggest you learn it. That's it. That's my presentation. Anybody have any questions? Do we have time for that? I probably went over. No, you know what? I only 22 minutes. Pretty good. Wow. Any questions? Slow. Walk first. Walk first. Go out and walk for a bit, and yeah, do it real slow. There's actually it's called Couch to 5K. It's a real popular thing on the internet. You'll find lots of programs for Couch to 5K. That's it. Yeah. Thank you. Thanks.
Cool. Last up is Sumit, who's going to do a talk on distributed databases. And whenever you're ready.
Oh, I need to join the Zoom call, right? Oh, okay. Let's see. Oops, that must be the wrong one. There's 2 links you said, huh? Only one Zoom link, right? Telling me waiting for the host to start the webinar? Is that what? Do I need to turn on my computer audio? No, right? Okay. Okay, sorry about that. Oops. You guys hear me okay? This one? Oh, so I can move? Okay, hold on. Turn off my own speaker. Yeah, there you go. Okay. All right, now. Oh, it's working. Hey, where's my thingy? Thanks everyone. So, gosh, I need to make it a presentation mode. I thought this is the first one. Yeah, so I'm not too big on a deck or something like that. Oh, I can't move, right? Oh, sorry. So I'm not too big on a deck or something, and I'm used to walking a lot, so I guess I can do both. Welcome everyone. So I'm going to talk about distributed database, particularly database called YugabyteDB. I used to work for that company, the company that makes that database, and I don't work there anymore. I'm wearing a Microsoft jacket. I used to work for Microsoft. I actually don't work for Microsoft either. I do work for a company called CGI, which I'm as a director of consulting expert and basically work as an architect. So in this talk, it's about distributed databases, and it's 20 minutes, right? So do you have your famous clock or not? It's okay. Don't worry. So it's about distributed database and what it does. And particularly, we'll show you YugabyteDB, of course. And also, I have a little demo, and I can take your questions, of course. And so that's a little bit about me, an architect, mentor, volunteer, in any order. Been with Microsoft, long time with HP, short stint with Apple, short stint with Intel and Ford. Also worked with a couple of startup companies, MongoDB and Yugabyte, both as a startup. Currently, like I said, I work for CGI, essentially as architect. I've been an education volunteer, so any of you are familiar with TEALS program here? Okay, there are a couple. So that's a program sponsored by Microsoft, essentially, that helps high school teachers deliver computer science classes. It turns out that there's not enough computer science teachers in this class. That's one of the reasons we have a shortage of tech workers here. And it's more complicated story, but it turns out that if you want to be a teacher, like you need qualifications and all that stuff in the state of Ohio, if you want to be a CS teacher, it's even more difficult to become like a CS teacher. Anyway, long story short, there's a gap of CS teachers, so there are volunteers who essentially go to schools and help teachers deliver the content. And there's a program called Mentors in Tech, which was actually a program that helps college students. So these are people who are maybe first generation into college or fresh coming from another country into this U.S. And they need some help in career guidance, like how to face interviews and how to take jobs and what to expect in a job and stuff like that. Interestingly, the Mentors in Tech program was started by someone who started TEALS when he was in Microsoft. And then I also teach cybersecurity courses in some universities, Michigan, Ann Arbor, and all those places, University of Florida. So with that, let's start with the talk, actual talk, what we're going to talk about. This is DB Engine's ranking. Is anyone familiar with this ranking table? Anyone here? Okay, 1, 2 people. Okay, there you go. So you know what? Okay, 4 or 5, I guess. So for those of you who are not, I keep moving, no. For those of you who are not, this is actually a ranking, and I'll tell you what the ranking is about databases. So this website, db-engines.com, or you can just look for Google search for database ranking, it will tell you that. It ranks databases based on certain thing. It's a method, and I'll go to the method a little bit later. And it will say like which is the most popular, which is right now, as you can see, is Oracle, versus which are less popular. Now, there are different types of databases, like there's relational databases, non-relational databases, transactional, analytic, data warehouse, blah, 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 big data, et cetera, et cetera. So what you don't see in this chart is on the left-hand side, you can actually group by them. So you can say, I only want relational databases, I only want cloud databases, stuff like that. It's a trivia question. Anyone knows who makes the most of money out of databases? You can use this chart, or you cannot, you can just close your eyes and tell. No, not accountants. I mean, as a software company, to be very clear, which software company makes the most money out of databases? Oracle, okay, any other guess? Microsoft. It's because they have all this, well, they include the cloud database revenue out of that. So the point I'm trying to make is that the database market is too crowded. In fact, if you go to the website right now, we'll see over 400 databases. And that includes, of course, cloud databases. That includes things like Snowflake, which is really getting popular, includes Databricks, includes all the databases that AWS, Azure, and Google offers. We're talking about Bigtable or BigQuery, I guess, earlier in the talk. So all of that stuff. So as a startup company to come up and offer a database, I mean, MongoDB was probably, and Redis also are two of the recent success companies. Distributed database companies have a tough challenge. Like they have they really have to be really good and address some of the challenges. So what you're seeing on column 1 is the rank in this current month, November 2023. October 2023, so what was the rank a month ago? Then November 2022 is what was the rank like a year ago. And the score, the number is based on a bunch of things, which is mostly popularity, meaning how many job postings are out there on the websites, how many people are discussing Stack Overflow open questions, how many resumes, et cetera. This is not based on revenue or any of that numbers, which is not really easy to do. And the green and the red arrows are kind of interesting. It shows a trend in 1 month or 1 year, which one is getting more popular and more less popular. If you go look for here, YugabyteDB is somewhere in like close to 100. So obviously they're, like this started 6-7 years ago. What is it they're trying to do? So this is from their slide. So this is a little bit of marketing, of course. And as you can see, you got databases in 4 different quadrants. On the left-hand side, we have things which are high performance but not transactional. We're talking, these are typical NoSQL databases like AWS DynamoDB, Mongo, or Cassandra, or Azure Cosmos DB. You can literally scale Cosmos DB, they say limitless. On the lower left-hand side, you have high performance and transactional databases. These are relationals of the world. They should have Oracle. I don't know why they don't have it. Anyway, some are open source on the bottom, like Postgres and MySQL. Some, which is AWS Aurora, which is technically really not a database. It's like a storage system, but anyway, they're not portable. And then you have Google Cloud Spanner, which is transactional and planet scale, but what YugabyteDB claims to do is add performance to it. So essentially, it's a database based out of Google's Cloud Spanner, which we'll see, what are the differences are. Okay. Any questions so far? I hate to keep talking on my own. No? Okay. Clear as mud. Okay. Cool. Architecture, a little bit. So I'm kind of mixing a few things here. I'll go through a few slides and then I'll show some demo. This is a distributed database, which means database does not run on a single machine, right? It's distributed across multiple machines. These nodes, 1, 2, 3, 4, it could be on-prem, it could be on a cloud, it could be in multiple clouds together. So technically, you can run one of these nodes in AWS, one in Azure, one is GCP, and one on-prem. And in fact, there is I don't think I cannot take the name, but there's a very big retail company in this country that ran their systems across multiple clouds like that, and they had an outage on one of the cloud providers. They didn't even notice that it happened. So this is one cool thing about going into databases like Yugabyte. By the way, there is another one called CockroachDB. You may have heard of it, which is very similar to this. In fact, they're competitors. They run the same way, pretty similar way. So essentially, they use a term called universe, which is basically a cluster. What would be a cluster in any other like lingo? And what you're seeing here is 4 nodes, so basically 4 machines, right? And they have 2 database processes, essentially, server process. One is called a master, one is called T server. So master is like a metadata management. It keeps track of where the tables, where the nodes, what tables were created. And T server is actually where your data resides. So your SQL engine is T server. So in this example, I have 4 nodes, and I have RF, that's replication factor 3, meaning each table is got 3 copies of data, right? So basically, the idea is that a table is split on shards. They call it tablet. It's nothing but shards, a horizontal split. And each of those tablets, each of those shards will have 3 copies, right? So shard 1 has 3 copies, shard 2 has 3 copies, etc. Now those 3 copies are distributed across 4 nodes. So let's say one node goes down, you're looking for a particular row on a table, your row may belong to a shard, and that shard may not even have existed on that node. So you don't care if the node went down. If your row did exist on a shard on that node that went down, then of course you have replication factor 3, which means you can have one node completely go down and still have 2 copies running, so you're completely up and running. You get the idea. This is very similar to Mongo or Cassandra or any other distributed databases. If you want more than 1 node failure as fault tolerance, then you end up having 5 replication factor, 7 replication factor for 3 node failure, etc. Right? 2n plus 1. Any questions? No? Okay. Cool. So this is what I said, tablet. Tablet is basically a shard of the table, right? That's the name. And if you have 3 replication factor, that is, tablet is replicated 3 times, you can afford to lose easily 1 node, possibly 2 nodes if you're lucky, like in this situation, like I explained. If you have replication factor 5, then you can afford to lose 2 nodes without losing any data. Okay, we're going to switch gears. So that's a very high-level architecture, node, cluster, universe, etc. We're going to come back to like APIs, like how do you access the database. So essentially, this database has, oops, sorry, I don't have too many slides on it, so I'll talk through it. Has 2 APIs. One is Cassandra, another is SQL. So you can treat it just like a Cassandra database, or you can treat it like an SQL, and by SQL I mean Postgres database. I'm going to show you some example of Cassandra. Anyone here knows Cassandra? Okay, one person, couple of persons. Okay. For the rest of the people, I guess little bit of. Does this thing work? Nah. For some, oh, it's off. Of course, it's not running. See it? Where is it? There it is. Okay. So there's 2 sides. First thing you do is create a key space. A key space is like a table space. If you're familiar with Oracle, basically logical structure. Every table has to be created inside a key space. And then you are creating a table. The key thing here when you're creating a table in this example is you have what is called a primary key. You need to have a primary key. You cannot have a table without a primary key. Over here, what we said is we got table T1 with C1, C2, C3, C4, 4 columns. And my primary key is composed of the first 3, so C1, C2, and C3. Now within that, you will notice that C1 and C2 are within a parenthesis itself. What that means is a partition key. So we're going to create partitions based on values of all possible combinations of C1 and C2. And the third one, which is part of primary key, but not partition key, C3, is a sort key. If you're not familiar with Cassandra, this will be kind of little bit new concepts. I'll quickly go over it, but just enough for you to know that you need to have a primary key, and because sort key is essential. So in the second example I have down, create table T2, we're creating a table, and we don't have a, our primary key, partition key is only one column, C1 column, and C2 is again a sort key. Okay, the table row is co-located with its primary key. Now, as you can imagine, like, databases has been around since 1970. If you think, E.J. Cord's paper was the original database, like a start of database series. There is a reason that there is, no solid distributed relational database, because it's very hard to do, right? So if you go the relational word database round, like Oracle or SQL or Postgres or MySQL, essentially it's monolithic. Essentially it's one place. Yes, you can have a DR, you can have replication, you can have all that stuff, but still it's pretty much located in one place. And compare with that, your MongoDBs and Cassandra and HBase and all of that stuff is distributed, but they're not relational, so they're not, strongly consistent, right? So if you make a data change, you may not see the data change immediately based on where you are, who you are, and all that stuff. Now, the way these people are trying to address this problem is essentially doing with lots of remote RPC calls, doing a distributed transactions and all that stuff, but it is hard. It is hard. So the point I'm trying to make here is that if you're familiar with Oracle, some of you must be, right? Oracle database here, right? So Oracle has this thing called index organized table, which is basically means your table is co-located with the primary key. Like, so in your storage, normally, in almost all databases, when you store a table, it's a heap table, meaning there is no ordering of how data is stored, right? So when you add records to a table, it essentially goes to some free block somewhere. There is no ordering of how the data is stored. The only exception is this, in Oracle's world, index organized table, which says that the table gets kept in the same order in primary key. So now, if you can read through the primary key, you're actually reading through the table as well. So here, a table row is co-located with its primary key, like Oracle IoT, and query using one value of PK columns is a single fetch. So in order to make your query very efficient, as you can imagine, if it's a distributed, query, you do want to go to the right place to read the right row, right? If you're doing a single record fetch. So you need to have in your query some select statements where you are going after your primary key. So for example, a table which has primary keyed on C1, C2, and C3, I would like to have a query which reads, can you see my mouse moving? Okay, you can. I need to have a query which reads something like this. I need to have an equality sign for C1 and C2, at least. If I don't have that, 5 minutes, okay, if I don't have that, then I can't, my query is going to be what is called a random query. In other words, it's going to look into multiple other things. So I thought to run a quick demo. I don't think I want to go into storage and all that stuff. Let me show you this demo that we have. And this is all running locally on Docker. So thing I'm going to show you is, let me do this. So the idea here is that we're going to create a distributed Yugabyte cluster on my own local laptop, but I will pretend I'm on cloud, and also I'll pretend I'm using 3 different continents, Europe, Africa, and America. So in my hypothetical scenario, and I will, basically, I have 1 node in Africa, 1 node in Europe, and 1 node in America. Now, the cool thing here, what we're going to show as it runs through it, is that it's going to show you a geo-distributed table. So in a single table, in a single relational table, I can have my rows, let's say 3 customers, customers in Europe, customer in Africa, and customer in America. American customers will be in America partition, African customers will be in African partition, and European customers will be in Europe partition. I'll show you, and this is kind of too many stuff here, so let me just chill one quick. Maybe I can show you the script, and that way it can make some sense. So if the green, what you're seeing is I have 3 hosts, Americas, Africa, and Europe. Everywhere it's running YugabyteDB, which runs essentially a Postgres API on this port. You can connect to this database. I'm creating a single table called transactions table. And then I'm creating 3 different table spaces. This is where the magic sauce lies, right? So I'm creating a table space called TS_Europe, TS_Africa, and TS_America. Anyone here familiar with Postgres table space as opposed to Oracle? Okay, so if you know that, then the way the Postgres table and table space and partitions works is little different from Oracle in the sense that I have created the parent table. I have created 3 different table spaces. The only difference between the table spaces are the names and where do I want to be located. So the Europe one stays in Europe, the Americas, and Americas, and Africa, and Africa. And over here, I created 3 partition tables, basically what's called child tables. So they're going to be structured exactly like this, except there are partitions. And this is a list partition. So what I'm saying is, if your value is in Europe, then go to Europe partition. So value in Africa, go to Africa, values in America, and go to America's values. And that's all the demo is. If I can go back and look here, you can see there's 3 records. So basically, you can have customers of the same table, and they'll be in different places. Exactly same table based on their locations. I guess that's about the demo. I can go a little bit more of this table servers and masters and all that stuff. If you look into it, it's interesting how the numbers keep on changing. But really, this is, by the way, oh yeah, one more thing I have to tell you before I finish is what is that YugabyteDB, like how we can play with it. And that is, the product itself is 4 of those actually. One is called YugabyteDB. That's the open source database. That's the one that I was running on Docker container. You can download it, run on a PC, Mac, Linux, Windows, anywhere you want. I don't know if you can write on Windows. Then you have YugabyteDB Anywhere. So YugabyteDB Anywhere is like when you will run the database on maybe on your on-prem machines or on IaaS on the cloud, a mix of on-prem and IaaS, like hybrid, etc. The third option is YugabyteDB Managed. So this is when you're going to cloud, but you're not like, you're just letting Yugabyte offer the cloud service. This is similar to, what is the Mongo service called? Is it Atlas? No, not Atlas. Yeah, Atlas. Very similar to MongoDB's Atlas. And the fourth one is Voyager. It's essentially a migration tool, which is kind of nifty. Basically, Gartner came and told, hey, we don't consider you as an important database unless you have a migration tool. So that's that's a migration tool. So essentially, these are 4 ways that if you really want to try it, try the database out. In the interest of time, I'll just stop here. I guess we're up on time. So any questions? I'll be here. If not, thank you very much.
So thanks everybody. That's our show tonight. And if I could get the speakers up here for a group photo, and you got to be in here because it's a big. Okay. Well, you don't have to if you don't want to, but again, huge help to Odd for picking this up. I didn't think I was going to be here, but again, thanks everybody for coming. This is a great group.